The objective of this lesson is to solve measurement problems using visual models. Realize that the purpose of this lesson is for the students to learn to model the problems in a visual way. There is not a specific right way to model each problem. 3 examples of different strategies will be shown, but allow your child the flexibility to represent each problem in a way that makes sense to them. In previous lessons, students have been given Paulia's problem-solving steps. These steps may be helpful as students carry out the problem-solving for problems in this lesson. They are as follows. Understand the problem, devise a plan, carry out the plan, and look back. Look at the following problem. Jose spent 1/4 of his money on a video game. If the game cost $15, how much did he have to start with? The first step in problem solving is to understand the problem. So first, let's determine what we know from the problem. Jose spent 1/4 of his money on a game. That game was $15. We are trying to find out how much money he had to start with. Let's write an answer statement to help us remember what we are solving for. Jose had how many dollars to start with? Now the second and third steps are devise and carry out the plan. Let's draw a model to represent this problem. This whole bar represents all of Jose's money. This is the amount we do not know yet. It said he spent 1/4 of his money, so let's divide it into 4 sections and shade in 1 to represent 1/4 of the money he spent. We also know that the amount he spent was $15, so let's label this $15. Since each one of these sections is also equal to 1/4, we know that each of the sections is also equal to $15. To find the amount Jose started with, we just need to add each section together. 15 plus 15 is 30, so these two would also be 30. 30 and 30 is 60, so we know that Jose had $60 to start with. The last step is to look back. Does this answer make sense? Yes, we can see that the model helps us to visualize that $15 is 1/4 of the amount that Jose spent, so 4 times that amount would make a total of $60. Karina can plant 2 flowers every 3 minutes. How many flowers can she plant in 3/4 of an hour? Again, we begin by looking for information that is given. We know that Karina plants 2 flowers every 3 minutes. We are trying to find out how many flowers she can plant in 3/4 of an hour. Let's write an answer statement to help us stay focused on what we're looking for. Karina can plant how many flowers in 3/4 of an hour? Let's use a number line to solve this problem. How many minutes is 3/4 of an hour? Think about a clock. If we divide the clock into 4 equal pieces, we can see that each piece would represent a 15-minute block of time. So 3/4 of an hour would be 3 15-minute blocks of time. Let's begin by labeling our number line from 0 to 15. Let's label it by 3s since she plants 2 flowers every 3 minutes. For each section, we can put a block to represent the 2 flowers planted every 3 minutes. Now, can you see? She planted 2, 4, 6, 8, 10 flowers in 15 minutes. Remember though, 15 minutes only represents 1/4 of an hour. We need to represent 3/4 of an hour. All we need to do is copy our number line 2 more times. This now shows 3 15-minute blocks of time, or 3/4 of an hour. Each number line shows that Karina is able to plant 10 flowers every 15 minutes. So we can see 3 groups of 10 for a total of 30. Karina can plant 30 flowers in 3/4 of an hour. Does the answer make sense? If 10 flowers can be planted in 15 minutes, then 3 groups of 10 flowers can be planted in 3/4 of an hour for 3 times 10, which equals 30 flowers. Let's look at one more problem and represent it in a different way. Ethan wants to make keychains for his friends. Each keychain requires 1 2/3 yards of paracord. How many feet of paracord does he need in order to make 7 keychains? We will understand the problem and begin with what we know. Ethan is making 7 keychains. Each keychain uses 1 2/3 yards of paracord. We are looking for how much paracord he needs. Our answer statement would be Ethan needs how many yards of paracord for 7 keychains. The next steps are to devise and carry out a plan. Let's represent the lengths of paracord with these rods. Since one keychain uses 1 2/3 yards, let's use this blue rod as the whole, or 1 yard, and these green ones for the 2/3. Now this is the paracord needed for 1 keychain. Ethan is making 7. So let's repeat this model 7 times. Now we can see the paracord lengths for 7 keychains. Using what we already know about fractions, let's regroup the thirds. We can use 3/3 to make a whole, and regrouping the blocks will make it easier for us to count the total length. Now, how many whole yards of paracord are there? Counting them all, there are the original 7, then 8, 9, 10, 11, and 2/3 of a yard more. Ethan will need 11 2/3 yards of paracord for 7 keychains. Looking back to make sure this makes sense, we can see the visual model for each 1 2/3 yards of paracord for the keychains. Adding 7 groups would make this 7 yards, plus the 7 groups of 2/3 yards, totaling 11 2/3 yards of paracord. Give your child the opportunity to solve a variety of measurement problems and encourage them to experiment with different ways of modeling them. The objective for this lesson was to solve measurement problems using visual models. We did this by using a bar model, number line, and Cuisenaire rods to solve word problems along with the following problem-solving steps.